So students, in this video we'll discuss about elimination of left recursion. See, this is in the last video we have discussed about minimization of context free grammar. Why we have to do that? To convert them into the normal forms. So CNF and GNF. So if you are asked to convert any context free grammar to CNF, Chomsky normal form, or GNF, make sure that the grammar should be minimized context free grammar. Means no null productions, no unit productions, no useless symbols, and so that's enough for CNF. But if it is GNF, then ensure that there should not be any left recursion also. There is no problem with the right recursion, but it should not have the left recursion. And even in the first chapter we have discussed about dealing ambiguity. At the time I told you how eliminating the left recursion or converting the left recursion grammars to right recursion may eliminate the ambiguity from the grammar. So how we have to do it? So that we didn't discuss much in that video, but in this video we'll discuss what are the kinds of left recursion, how we have to eliminate all those things, right? So first, what is mean by left recursion? Uh, if a non-terminal is occurred as a leftmost symbol in the production, that is left recursion. And right recursion means rightmost symbol. First of all, what are the types of recursions? See, we have left recursion means if you have like this, A tends to A alpha, right? If the left hand side non-terminal is occurred as a leftmost symbol, then we can say that left recursion. Right recursion means if the left hand side non-terminal is occurred as a rightmost symbol in the production. It can be in any production, not only in the first production, can be in any of its production. General recursion means it can be anywhere, somewhere in the middle or something, right? Without recursion, you cannot generate the infinite number of strings, right? Then we are having this. So same way. So left recursion means the non-terminal, you can see this. Okay. Then right recursion, then general recursion. Of course, epsilon means just we have given the termination condition. Otherwise, it won't be useful productions, right? Then coming to this. So if it is left recursion, then we can say that left recursive grammar. But the problem only with the left recursion grammar, but not with any other. What is the problem with the left recursion grammar? Why we are focusing only on left recursion? So there is a danger of fall into infinite loop when you are going for the top-down parsing. Means, see, for the A tends to A alpha, you are substituting A alpha, A tends to A alpha, like that. Means for A you can take A alpha. For example, if you take the backtracking for A, you can take A alpha. For A, you can take A alpha. Like that, there is a danger of falling into infinite looping in some parsers, right? So there is a problem with the left recursion. So to do that, we have to eliminate the left recursion. How can we eliminate it? Simply, we can eliminate the left recursion by replacing the productions like this. If you are having here A tends to A alpha beta, that we can eliminate by rewriting the production like this. Okay, so what is the meaning of it? See, if any production is in the form of A tends to A alpha or beta, means where you are having the left hand side non-terminal as a starting symbol, that can be taken as A. In that production, remaining all the symbols are treated as alpha. And where you don't have this A as a first symbol, that should be taken as beta. Once you identify the A alpha beta, simply substitute here. A tends to beta A dash tends to alpha A dash or epsilon, where this A dash is any new non-terminal. There is no restriction that we should take only A dash, right? So you may get a doubt like what is A alpha? Then let me go with this example here. Okay. So then here we are having A tends to A alpha or beta. But as I told you, when you can say that it is left recursion, if the left non-terminal is occurred as a leftmost symbol, then the remaining all will be treated as alpha, right? Then where you don't have it, you can take it. So automatically what we can write here, so you can write in this way. A tends to, what is beta here? Beta only, and A dash. And A dash tends to, what is alpha here? A alpha is the new alpha here. A alpha, A dash or epsilon. That's it. See, We don't have any left recursion because this is A dash, this is A, right? So don't get confused with this, right? Let me go with the another example like this. So how to eliminate the left recursion from here? See this A, this you assume that A, and wherever you are having this left hand side non-term as a first symbol, you can take it as A, and remaining all are alpha. And again we are having A here, remaining all are alpha. And where you don't have this left hand side non-term as a starting symbol, that you can take it as beta, right? Then here we are having 2 alpha, but we have taken the formula as only 1 alpha earlier. Then what we have to do if you are having more betas or more alphas? Let me go with this same. If you are having only 1 alpha, you have taken one time, 1 beta like that. So what if you have more than 1 alpha, like A alpha 1, A alpha 2, so on, A alpha n, if you have like this, and beta 1, beta 2, so on, beta n. If you have like this, you may have like this, right? So there is a possibility of only 1 alpha, 1 beta, like many alpha, many beta, beta m. Then you can write in the same way. You can eliminate like this. A tends to, if it is only 1 beta, you have taken one time. If it is m beta, take m times, like beta 1 a dash, beta 2 a dash, so on, beta m a dash. That's it. And if it is only 1 alpha, you have taken one time. If it is n alpha, you take n times. Alpha 1 a dash, alpha 2 a dash, so on, alpha n a dash, like that, or epsilon. Epsilon is only one. Same you can apply here, right? Then how to eliminate it? So this is alpha 1 and alpha 2. Then you can write a tends to beta 1 a dash. We are having only one beta, then you can write beta 1 e dash. We don't have two betas. Then e dash tends to, we are having 2 alpha, then write 2 times, plus e dash, or star e dash, or epsilon. That's it. This is how it is going to be eliminated. Okay, you can see the answers here for the same grammar, right? So here they have taken, instead of e dash, they have taken a new non-terminal. That's your wish, whatever you want to take. New which is not exist in the grammar. We have taken e dash, they have taken a, no problem, right? So then what are the types of left recursions? We are having two types. One is direct left recursion and another one is indirect left recursion. So what is mean by a direct left recursion? See, if a non-terminal is having left hand side same symbol, right, a or beta, so this is direct left recursion. Means if the left hand side non-terminal is occurred as a first symbol in its production, single and arrow means production, then we can say that this is direct left recursion. So what is mean by indirect left recursion? If A derives, after substituting any number of productions, if A derives A alpha, then we can call it as indirect left recursion, right? Direct means A tends to A. Indirect means A derives A. See, the wording is different here, guys, right? Here I'm saying that single and arrow means A tends to A alpha, and here A derives means you substitute any number of productions. Then how to get that indirect left recursion? Here, for example, I want to check whether there is an indirect left recursion. Yes, we have to check it. See, for S, first check, do you have any direct left recursion? No. To get the indirect left recursion, you have to substitute any production where you are having the first symbol non-terminal. If you don't have, then you never get the indirect left recursion. Yes, we have. For example, if you don't have the first symbol as a non-terminal, you never ever get the indirect left recursion. So substitute AA, right? Then we have substituted one production. So for this A, by substituting any of A production, is there any possibility of getting S as a first symbol? For this A, we have three possibilities. By substituting any of these three, is it possible to get the S as a first symbol? Means yes, SB. In place of A, I am substituting SB, then it would be like this, SBA. Now see, this S is occurred as a first symbol here. So this is called indirect left recursion. Okay. So same way, you can check for the A also. Of course, A is having direct left recursion and there is a possibility of indirect left recursion also. How to check that? For A, If you substitute AC directly, we are having, right, direct left recursion. Then you substitute SB because we are having AC here, right? SB. So for this S, if I substitute any of S production, is it possible to get the A as a first symbol? Means yes. You can take AAB. In place of S I have substituted. Then again A is having the direct and indirect, both left recursion for A. Then how we have to eliminate the indirect left recursion? See, direct left recursion I told you how to eliminate it. Just simply substitute in the formula, whether it is general formula or normal formula. We have discussed both here, right? So for the indirect left recursion, what we are supposed to do? See guys, if it is indirect left recursion, either you have to substitute A productions in S or S productions, right, in A. You do any one. So if you could able to eliminate the indirect left recursion and convert into direct, then we know how to eliminate it, right? So I'll substitute all the S productions in A, right? I'll go with all the S production, second option. Then you can do this. S tends to A or D, and A tends to, in place of S, substitute all of its production. Substitution rule we have discussed, right? So what will be happen in place of this S, substitute A, then you'll get AAB, and substitute D, you'll get DB, and AC and F. Now see, we don't have any indirect left recursion. You check it. S tends to A. For this A, if you substitute anything, you won't get the S. For the A, no other non-term is occurred as a first symbol, so you never get it. And if you substitute A's productions in S, what will happen? You can take this. S tends to, in place of A, substitute all, you'll get SBA, ACA, D. See, the recursions have been increased instead of decreased. We made it again direct left recursion and indirect. S tends to A tends to S. So there is a reason you check both the possibilities, but definitely one possibility will eliminate the left recursion, the indirect left recursion. Now see, we don't have indirect. Now we are having only direct left recursion. And you know how to eliminate the direct left recursion. Then see here, see we don't have any direct or indirect left recursion on S, and we have indirect left recursion on, sorry, direct left recursion on A. Then you can take this as A. Wherever you have A, then take it alpha 1, and we don't have this can be treated as beta 1, and again we have A, then it is alpha 2. We don't have A as first symbol, then we can take it as beta 2. So how to eliminate the left recursion? You write only A production. A tends to beta 1 A dash, means dbx. A dash means, as I told you, you can take any new non-terminal, and beta 2 new non-terminal, that is x. And what is new non-terminal? Tends to alpha 1 x, abx, or alpha 2 cx, like that. So you can convert first the indirect left recursion to direct by substituting one non-terminal productions in another non-terminal, then make it direct. Once you got the direct, and you know how to eliminate the direct left recursion, right? So sometimes you may have the first production in second or second production in first, but you have to do it manually. You have to substitute all and try to do it. Okay, so this is how we have to eliminate the left recursion. As I told you, the main problem with the left recursion is danger of fall into infinite loop, and it is useful only in the conversion of context free grammar to GNF according to ALC subject. But in CD, in all the top down parsers, that is a problem with the left recursion. So either way, you have to eliminate it. So in the next video, we'll discuss the normal forms of context free grammar, especially Chomsky normal form we'll discuss.